And on to the next set from box number 4. So he sent in 2 communicator NI440DX. It was LCL who brought the communicators in, so I'll refer to them as LCL communicator. So this is the nicer looking one of the 2. The other one is hand painted and has the TX light missing and rattles. Now I don't normally select which one to do, but I thought I'd go for this one first. They're both the later versions with what I call the clear meter rather than the early version with the yellow meter. So we'll see how it goes. So once we've done these, we move on to box 5, and I understand it is a Uniden 200 or an audio line 341 or something like that. Just making sure there's nothing scary inside, and there isn't anything scary inside. I didn't switch the soldering iron on, but in the meantime I can be connecting it up to the test equipment. So it's a square type power lead, which is hard to come by. Should be the same Cybernet wired microphone as we used on the Cybernet. Possibly only needs 3 connections because the radio has a relay in it. So the receive is probably done automatically, shall we say. This doesn't look messed with. Just looking at capacitors and they look alright. Can't see any of them poking their guts out. Switch the power supply on, switch the radio on, and of course we're not connected to power, are we? Duh. So it's which one's positive and which one's negative. Hopefully it's got a hopefully it's got a negative earth chassis, so we can put the test meter on, put one probe to earth, the lower one is open, this upper one is short, so that tells us negative is to the top. So I'll put that one on the pin and that one on the inside, and then for once in my life they may not even short out, which will spoil my fun. I don't like the fact it's got a LED, but you know. So let's go into transmit. I've got a second-hand piece of paper here. So NI440DX, and I'll put good one. This might turn out to be the white elephant. So on transmit, I'll switch some other gear on. On transmit it's doing 3 watts. Let's look at whether it's on frequency or not. So we should be on 27.79125. Let's just pull that up while I'm here. So the reference crystal, there's the synthesizer, there's the reference crystal. So the reference preset capacitors there. they drop naturally with age, so it's not surprising now that they're 40 years old. Just have it slightly high. Then it's got a bit of headroom to drop. Let's go back to the other display. Let's look at deviation. Wow, it's about right, that. It's just very slightly high. So that needs pulling up, that needs correcting, that's being corrected. Let's look at receive. So we've got 0.3 microvolts on the signal generator. Just make sure the RF gain's up. Yep, that's all how it should be. So let's look at the synad meter, and then we'll adjust till we get 12 dB. It doesn't sound right, I will tell you that. RX is 1.6 microvolts for 12 dB synad. I wonder if it will ever do 20. It will. It is 1.85 microvolts for 20 dB. I'll tell you what, we'll just do 10 while we're at it, because I can't remember how they specify it in the instruction box. 1.6 also for 10. 1.6 microvolts for 10 dB. So we'll check those later, because it's the receive which people find difficult to do on these, with it not being normal, shall we say. So we'll start with the, I'm going to try and do both these sets either in one day, because we're doing repairs, CB repairs at one a week. We're having the 19,000 hour organ restoration on my hands, which will take a year. So we're just taking a bit of time out to do these CB repairs as a courtesy. Now, is that the right? You know what? I think that's the right one. That's the right one. Good. So, here goes. We don't have any specific instructions for the VCO, so we're going to check it transmits on channel 40. It does, and we're just going to check it transmits on channel 1. No, it doesn't. So we're going to have to come up with a workaround on this. The chances are the trimmer here is going to be the VCO. Dare I just adjust it a tiny bit? Not wanting to do all 40 channels, is it? I think we're going to have to look at I'm going to have to think of a way of setting the VCO in comparison with sets we know how it's done with the same synthesizer. I've never had to do that in all the years I've been working on these, so whether or not we've got a component on its way or whether it just needs aligning. So that has been fiddled with, which is a shame, and I could see that the wax in the coil's been fiddled with. That's one of the things that alerted me to that. Not quite sure what that's about. It's a green wire which kind of looks a bit aftermarkety. So we'll come back to the VCO, but what I'm wanting to do is to just whip through the transmitter. That's in the middle. That's in the middle. That's in the middle. That's in the middle. And just change tools. That's peaked. We'll go over to the range now. Just warm that up. Right, we'll just run through those again. It's only just doing over 3 watts, which is fair enough, but it's doing about 3.2 watts, so it's it's on a par with new sets. We could start fiddling around with the ballast resistor there, but we're not going to fiddle around with the ballast resistor. The set's managed to make it on. At least we've got about 0.2 more than it came in with, so we know it's right. So we'll just check low power's right while we're at it. Where's low power on these sets? Don't tell me it's on the... It is, it's on the back. So it should be 0.4 of a watt. It's 0.7, so that's got fiddled with. So it's the preset there. So that's now 0.4. If I can get the tool back out. So that's that set. Let's look at deviation. So it's the preset there. Wallow, it's still over the top. 1, 2, that's it. 2.2 to a very maximum of 2.5. So it's about 2.8. You just don't want it to be splattering onto other channels. And the meter, let's just see it. Now, I know it's only I know the radio is only developing 3.2 watts, but we set the meter to read 4. Did I put it back to 4 watts? I didn't know. It should be right in the middle of the red zone, and it is. It's a little too much into the red zone, so we'll just pop that down a fraction. If I can just see where that is on my diagram here. I think it's the one at the back there. It is. That's now reading on the 4. So I know it's a bit of a lie, but that's how it is. So that's the transmit, but I say we will be revisiting it with the VCO. Now the difficulty with these is the receiver. And I say it does sound lousy, and it's performing lousy to go with it. So we'll start by looking at the detector. So I'll switch the oscilloscope on, I'll turn the bench light off, and we'll put the camera on the oscilloscope. I've said a million times it's only connected across the speaker, and any old oscilloscope will do. All we're looking at is audio. So the detector is the coil just there. And it was already spot on, and that surprised me. Right, we'll turn the oscilloscope off and we'll go to the sine nav meter. So what we now have to do is to try and get this needle over to the left, and as it goes over to the left, reduce the attenuator on the signal generator so we're not saturating the radio, so we can actually see some adjustment taking place. I would suspect we're going to start at this end. It's a very slight improvement. No improvements. No improvement. Slight improvement. Slight improvement. Big improvement. I think that's it. Just see how it... No, it still sounds lousy. Okay, so meticulously gone through that several times because they can be interactive. And I also failed to realise we've got this coil, which is the amount of injection from the synthesizer's receive 10.695 into the receiver. So that made a difference as well. So now, if we look at that, that's now listening to it at 0.3 of a microvolt, which isn't exactly going to get us all excited, But can we hear it any lower? We can actually hear it to about 0.17 of a microvolt. So let's get a reading now. So for 12 dB, it's now 0.63. So 0.63 from 1.6. For 10 is 0.59. And for 20 is actually, well, I'm between scales as usual. It says 1 on that scale, and it says, oh, it says 1 on that scale as well, so it's 1. So yeah, it's made a huge difference. Wow, great, that's what we want. So we'll go to S9, which sounds half decent, and let's go to the attenuator controls, and we'll look at where the meter is. It's between 7 and 9. It's not that far out. It doesn't make any difference really, I don't think, at this point. S meter is this preset. I'm going to have to change glasses to see that. Oh yeah, it's that one. And then we just need to check the squelch. Now squelch works well on these, if I remember rightly. I knew somebody who, back in the day, in 1982 or 1983, and actually asked for one of these as a wedding present. So I'm going to put the squelch to full, and we'll see when it comes in. I'd like it to come in at 100 microvolts, which is S9. So let's see. 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. Comes in at 300 microvolts. I'd like it more sensitive than that. So we'll just give that a twiddle. So it's the preset there. That's it, exactly where I want it. I've got a huge... Can you see this spider crawling up the test instrument? My picture-in-picture spider. Where's that come from? Okay, that's put me off. Without touching the spider... oh, we're going to check the lower sensitivity of this squelch. So I'll turn the signal generator to standby. Turn the squelch right down. Set it to threshold. Switch the signal generator back on. It's just about straight in. Go on, move. Go over there. So it's doing like... It's coming in at, it'll come in at 0.25 of a microvolt. Sorry, I'm lying to you. It leaves us at 2.25. Comes in at 0.35, leaves at 0.25. It's a very good squelch. Right, so the radio's done, but I just want to do the VCO. We're going to have to come up with a fix for that because it isn't good enough as it stands. Because this isn't going to work right in dodgy weather. So I'm going to look at some equivalent radio circuits where we know what the instructions are for the VCO. I don't want to just monitor the lock detector pin as the phase lock loop. I mean, it's been in this room, and this room is heated, so there's no reason for it to... We'll go back to channel 1. We'll put that back. So it's doing channel 1. It's doing channel 40 now, but it didn't from cold. So as the radio's warmed up, it's now working. But I just want to come up with a proper reading. So I'm going to do some research, and we'll come back to you on that. Right, so we'll go through this together to come up with a fix for the VCO. So there's a blow-up of the circuit diagram. So we've got the synthesizer chip. I'll just take picture in picture off, if it isn't already. Oh, I don't think it was ever on. Don't tell me I've done that. That was my fault, not the machine. Right. So, reference crystal coil that gives the output to the receiver, and then we've got CT1 and L1. So if we compare that to the popular Cybernet 134 chassis, of course this is a scan from the instruction book with the circuit diagram, so it's blown up out of all proportion. So T1 is going to be the same as L1, and CT1 is going to be the same as their CT1. Now, resistor 4 is the test point, and if we look at this, test point 1, resistor 4, it's where it joins with C7 and R11. So C7 and it disappears off. So it's the far side. So have we got an equivalent on this set of to use as a test point? So pin 15 of the chip goes to resistor 4. So let's have a look. Pin 15 of the chip we've got capacitor. Pin 15, we've got a resistor, a capacitor. We've got a resistor, a capacitor. We've got another resistor. So chances are our test point looks like it could be a resistor 2 far end. That's a point at which to try it anyway. But what is resistor 2? Well, we're going to have to look on the board. Right. I've got resistor 2. Of course, which is the far end? Is anybody's guess. But we can try and monitor it there. Wouldn't it be nice if it just said TP for test point? And we'll get the meter out. I'll just pop the camera back to its normal position. We know that chassis is negative, and let's go on that resistor 2. Well, you know what? It's what you'd expect, isn't it? The channel 40, 4 volts, channel 1, 2.9 volts. That is just the swing you'd expect for receive. So let's look at transmit. So we'll start with channel 40, press transmit. 4.17 I would think is a bit high. So, and my test prods come off. 4.01. Let's see where we are on channel 1. Channel 1, 2.95. Channel 40, 3.98. So we'll now say that test point 1 is there. So 4 volts, channel 40. So I've now been going 40 years doing these. I've never had to do that. It's something we can check each time. So we'll finish this video. I'll put this back together, and then we'll finish the video by. See, yeah. Going back to channel 20. And I'll put the lids on it. And when I come to this another day, like to do the on-the-air test with Mr. Chippy in a few days' time, we'll be able to find out whether the radio is still working on channel 1 and 40. So, without there being a component failure, what more can one say? That's found a fix. So I'm going to do the other when I've done this one. Next time I can spend some time on CB radios, I'll do the other one, which is in worse condition, and we will see. It probably works better. This is what I've said in the past. When we had a television and audio shop back in the late 70s, we used to do a lot of reconditioned television. We'd buy ex-rental television sets from the wholesalers, 10 at a time. And of course, we're going back to an era where most tellies were black and white. And for those of you in the UK, you can still have a black and white TV license and pay £50-something instead of £150-something for a colour one. So, and I'm still recording this in 2022. About time they abolished it. It's a ridiculous thing, the TV license. One of the reasons I don't have a television. We're in the middle of nowhere, very, very poor reception, and if you think I'm paying £150-something, I'm not. So since it went digital, not had a television. So we used to buy ex-rental televisions, and the ones with the posh cabinets, which were all in lovely condition, as often as not, they had the worst faults. And the ropey-looking cabinets often had the best electronics, so it was better to spend some time on the cabinet. Right, there we go. So we'll put it on the aerial in a moment. I'll just put these screws in. So we've got a right wind. Say that again. We've got a right wind at the moment, so I bet my aerial's all over the place. Oh, of course, we need to plug it in, don't we? One Anna Roger. $19 a Roger. Okay, well, it's not going to talk to us. It is 10 o'clock on a Saturday morning. So I'll leave that on. And thanks for watching the LCL Communicator NI440DX late version from 1982.